Now I got you, you fluffy, delicious little son of a mother. At any rate, why is that first part of the code stuff that I was teaching you? Because this stuff up here becomes the 0 or -1. It's got to understand that 0 equals -1 as well, which is in this to function about doing that lambda stuff. It doesn't need to do all that stuff to make the lambda work. I can do some sub pieces to it, but there's some kerfuffle between whether you should use else, not else, if else or something like that, to kind of reference like skip the step. I want you to jump over it, but it's kind of janky because it's going to have a problem with all kinds of other computers getting that little piece of it to just do the date, or I want this to be the clock in and clock out function because these are actually going to an hour somewhere, I do believe. I think this one's it. Yeah, because 39. Yeah, in there. So that pops it up in that superposition, kind of like knocking the atom out of the machine and dropping it onto a data table, because I had X and Y positions, and over those things they just kept slamming in there about what it was, and they might have been correlated to a certain building index because the name, the style, the dot equals the inside of the bubble next to print clock in station is going to be quite a build inside of here. So knowing that, we can do a list. We can do lists and groups and other things that do the same thing. And on the first row, there will be a difference in the result in the machine. It'll blink binary 0, 1 in terms of that clock unit on a figure 4, right? So we're getting up into here, kind of this thing being all this thing. It's dropping an order down into Billy, and Billy is this 0 in source code stuff. I mean, we're still trying to figure out, now that it does that, I want to be able to graph this in physics to a physical observation, right? I want to say, all right, so here's the space starting from the middle of the integral, and that integral is now my line. Because of that, it's going to be a rectangle like this, and I want my 1, what is the highest probability to be here. And so you'll start to see this hydrogen helium argument, right? Or the ions, or time dilation at the Big Bang level, stretching it out, having spin, any kind of thing like that from this array standard. So not only can we do that in the second order when this thing is A1, that, we could brick that right over, but sometimes it's nice to be able to pull these inside of here and just have, well, the main office is Mello's job, and the building is all these groups right here, and I'll have that on a specific sheet, and I want to combine multiple sheets inside of the system. That's going to require me to do some kind of core research and model on what I'm doing, or have these notations in a list, like, well, how many of these are they annual on some sticks, or do they come in certain wild indexes? Because an inside pulse would stand out against all these common bars. And to be able to do all that, again, let's see, I got something else I can use for you. Let's use this. Gets me a danger noodle. In this specific danger noodle field theory is a very important dragon to know. And whether you're a gardener or anything else out there, for what the reason is, there might be 6 in there, but whatever. What this is going to do. Now, I do my W minus boson in there as well, but technically I don't need it because this is a more base equation. It'd be the weird genophysiology of staying at the even distance of the light, but even then there would be square law about the light cone, AC, DC, battery, power source hooked up to the wall, that says there could be a way I could zero that out and argue that the nutrients, now that it's starting to take out because water was there, and one of those additional indexes was put water into it, and that gives me all this bit and block that I need so I can get the candlesticks right, because now we can cut this in half and say, well, I'll walk in the process out to this compressed candlestick of an entire day, or in this case what looks like 1, 2, 3, 4, 5 days, inside of results to a date. And again, when you constantly index, you kind of want to see it. Well, I was a little early, a little late. I was negative 272.998,999, or well, 997, 996, 999, because that would be like a whole order out in the Bohr's model that is going to cause something from up here to glitch a little bit. This one would also probably sub glitch across the board if I could run the series. Now, it took me 2 days to grow this one, plus rooting and some other things at 0, because there was no change. Water still moist, still the same humidity, most likely not over a full day. But let's say it's Schrodinger's cat in this box. So you're going to find things that it could not have done other things unless it tracked a certain way. And to be able to understand that about the moon, or how the combination, again, what we would know, again, we're looking at Pangea after the moon, right? And then continental drift for the game we're playing inside of the system. It's not for the meek, man. If data that can't figure that out, just I can't make that happen, Picard, about, well, you got to still get the fuck in there. Any rate, ConUS, same number, same corner, same A1. Now I'm throwing Alabama down into it, right? Now I'm just saying that there's some kind of planar space, or what is it, Hoffman space, or those. If you're watching, you're quick, you would notice things. You would see things. You would be, oh yeah, this guy's gonna be trouble, especially with these all so close together, like that Octopus Lady Tharp stuff inside here, Zach Star. So you get in the Smith chart, angry cores. The zoo. Kentucky Ballistics with the 50 cal slap round. Put a thumb in it. Alex Steele banging out steel coin inside of here.